Okay guys, I'll be doing the live demo of this project real quick. So I'm just going to go ahead and run real quick to my terminal and run the docker command. So I'm going to run the docker command in my lab space, which is there we go. And essentially when I run this docker, what I'm doing is I'm actually spinning up that Oracle server, which is basically a Python backend script. And all that does is it does the encryption and decryption for you. That's about it. So let me have it set so. It runs on port 6000. With that being said, I'm going to open up another terminal on the side and immediately run my attack script. And essentially with this being said, the attack script is connected to our Oracle server in port 6000. It's getting the 2 bytes, C1 and C2, or the 2 blocks I should say, the 2 blocks of 16-byte ciphertext, two adjacent blocks, C1 and C2, as the schematic showed. And what it's doing is it's actually taking the C2 along with a guess of C1 in each iteration, changing each byte of C1 255 times and seeing which byte of C1 a combination would satisfy that padding vector, as I mentioned. And you know that the whole concept is that if you know the padding and you know your C1 with the iterative guess, then you can find D2, which is basically the output of your C2 block. And yeah, that's really the essence of this. It's Python 3. Run that Python 3, and there you go, that's your message. And if I do this again and I run it, there you go, that's your message again. Now mind you, your C1 is always going to be different because of that initial vector that comes in each time, and that's your C2. So if I do it again, C1 and C2, it's going to be always a different combination, but your message is going to be the same. Why? Because you found that combination of CC1 prime that gave you the same padding of 1010101010. You know, that padding, like I said, you query that server for that padding, and so there's only 2 ways, right, for every possible combination. And that's it. I think that's really my demo. It's a pretty quick. Like I said, it's a little bit of a deep science, and it's not the moment to go through that at this point for this scope of the capstone, if you will.